So now when we are discussing about shell scripting and all, now we have to understand one more thing over here. So when you are writing your shell scripts and when you are executing your shell scripts, now where do we save our shell scripts? Okay, not only shell scripting, not only any program you write, guys. So going forward, we'll be writing our Ruby script, shell script, Terraform script, Ansible script, right? So when we will be writing all these scripts over here, so we need to be having one storing point for our all the coding part that which we are doing over here. Okay, so to store your all the coding part, we have one system which we use over here onto the DevOps side, which we call it as version control system. Okay, so using our version control systems, okay, we'll be storing the entire code that which we are writing over here. Okay, so we call this as VCS. So again, in our VCS, we are having two types of VCS over here, guys. So when you see version control system, under version control system, again, we have two types of version control systems. Okay, so one is DVCS. Okay, so DVCS, one is CVCS. First, let me tell you about CVCS, which is our centralized version control system. Okay, and the other is DVCS, which we call it as distributed version control system. So one is CVCS and the other is DVCS. Now let us first understand what happens at CVCS, which is our central version control system. Okay, so for example, you are a DevOps engineer, guys. Okay, this is your machine, or let it be a developer's machine. So whoever is writing the code, okay, you have one developer in your company and you have one more developer in your company. So like this, you will have multiple developers. Okay, so let us say this is our developer one. Okay, he will be writing his own code, right? So this will be a developer one. He's writing his own code. Let him write it in Java, JSP, Node.js, shell scripting, Ansible script, any script. Okay, so whatever code he is writing, okay, whichever code he is writing over here, right, he will be writing the code. Now in the same way, you will be having your developer 2 as well. Okay, and he will be writing his own code over here, right? And this is his code. Now when your developers are writing the code, okay, or as the DevOps engineer, you are writing the code, so you will be having your team leads and managers, right? Who will verify this code? Our team lead and manager will verify the code, right? So if you want them to verify the code, okay, they will be verified by your team lead and manager, right? Now over here, okay, one situation arises over here, one problem, and the problem is, whenever your team lead or manager wants to verify the code, should they come to your machine and should they verify the code from over here? Or the team lead or manager, should they come to your machine or should they verify from over here? Right, if one or two developers, okay, 500 developers means, if there are 1000 developers are there means, it will be a huge problem for them, right? They cannot go to each and every developer's machine and they cannot verify the code in this way, right? And that will be this way, yes, time taking, and they cannot, okay, validate the code also in a much better way, right? Now the same problem has been rectified with our version control system. So in CVCS, what happens over here is, okay, we'll be taking one more central server over here. Okay, so this central server, you can call it as central repo or central repository. Okay, we call it as central repo or central repository. Repository is nothing but a storage. Okay, whenever you see repository, it is nothing but a storage point, a storage part, right? So now what happens over here is, your developer one, when he writes the code, he will be push the code to your central repository. Same way your developer two also, what he does, he also pushes the code to central repository. So if you are having 500 developers also, they will be pushing the code to central repository, so that it will be very easy for your team lead or manager to check the code from central repository. Okay, and that will be the central point. And for comparing one code from other developers code also, it will be very easy for your team lead or manager to check and verify the code from over here, right? Because this is a central repository. Now they can easily check and verify your code from your central repositories, right? So this is the biggest advantage you will be getting when you are having central repositories over here. Okay, now everything is good. Developers are pushing the code, your team leads and managers are verifying the code, and they are passing the code. So everything is working fine over here. But there was a huge problem with this setup. Okay, one bigger issue was there with this setup over here, and that issue was, okay, this is our central server, right? What happens if our central server goes down? Okay, so this is my central machine, this is my central code store repository. If it goes down, okay, then that is a huge problem for us. Your developers cannot push the code, they cannot verify the code. So till the time your system administrators take back that machine again, they will be activating that machine again. Till that time they might take 3 hours, 4 hours, or 1 day of time. So that whole day our work stops. You cannot be verifying the code, they cannot be pushing the code, they cannot be checking the code. Okay, so because these central servers previously they were running on premises setup, and this was a huge problem for them. Anything happens to the server, okay, there is a lot of downtime which is going on. Yeah, on premises setup, CVCS, right? Now coming to our DVCS, okay, but architecture wise it's a very good architecture. Architecture wise, the way CVCS is working, the way your developers are pushing the code, and the way your team lead or manager are verifying the code, architecture wise this is the best architecture. But the problem was, as it was on premise, and if anything happens to my central repository, there is a huge problem over here, right? The same problem has been rectified in our DVCS system. Okay, so under DVCS, okay, architecture wise it's same. See over here also, you will be having your developer one machine over here also, okay, and over here also we'll be having our developer two machine. Okay, and what they'll be doing, okay, they will be writing the code over here, right? So I have my developer one, okay, so developer one will be writing the code, and the same way I have my developer two, okay, and developer two will be writing his own code, right? And over here, okay, he's writing his own code, okay, and over here he'll be writing his own code, right? And then we'll be having our central repository over here, right? This will be our central repository. That's why I said architecture wise you will not find any difference over here in between them. Okay, so architecture wise they are, okay, very much similar over here. So in the same way over here we have our, okay, central repo, right? And then you have your team lead and manager who will be verifying your code from over here, right? So they will be verifying our code from over here like this. So we'll be having our code and they'll be verifying the code from over here. Okay, so architecture wise the same architecture. You can say, sir, architecture wise there is no change over here. Okay, yes, architecture wise there is no change, but the way DVCS works, it's completely different. Okay, so now how DVCS works over here is, your developers will be pushing the code, they will be verifying the code, but now your DVCS method, your central repositories are over here in cloud, guys. Now, okay, so these central repositories, they are working in cloud now, and you are having two very popular central repositories for us. Okay, I hope you have already known with the names, that is Bitbucket and GitHub. Okay, so Bitbucket and GitHub are very two popular repositories for us, guys. Okay, so Bitbucket is an Atlassian product which is mostly used in real time, and GitHub is our Microsoft product which is also used mostly in real time, but Bitbucket is widely used. Okay, so your central repositories are not hosted in on-premises setup now; they are being hosted on cloud. And as I'm telling you that they are being hosted on cloud, which means 99.9% your central repos will not go down. They'll not go down, right? And 99.9% they are not going down. Okay, what about if you take the 1% remaining over here? Okay, if anything happening to my central repo, or if it goes down, what happens in DVCS method is, the code which you are pushing right to central repo, the code will be available on every developer's machine over here, guys. So if your central repository is down also, your code is distributed over here. It is not only stored at one central point only. Your code is available at developers one machine, developers two machine, developers third machine. So code is being distributed over here, not only at central repo. Your code will be available at any point, any developer's machine. Your team lead or managers could be coming and they could be checking the code. Entire code will be available on to this team of developers over here. So that is a one more major benefit, that the code is being distributed over here. Okay, yes, the code is being distributed and you have your central repository which is running in cloud. Okay, so if I take you guys to our central repositories over here, okay, if you check the central repositories over here, you will see, okay, that how your central repositories looks like. Okay, so if I go to our Chrome page over here, okay, and if I go for Bitbucket, okay, this is the Bitbucket's central repository page, guys. Okay, so if I log out from my account, okay, if I go to GitHub in the same way, and if I log out from GitHub as well over here, so this is your central repositories. Your central repositories are hosted as, okay, your central repositories, okay, they are hosted as your website URLs, guys. That is the reason I said that there are high chances that nothing will happen to your central repository, because they are running as URLs. They are running as website URLs over here. So whatever code you are storing, that code also will be stored as a repository URL only. And your central repositories are running as URLs. So if you see your websites, 99.9% they will not go down. Okay, so our central repositories are GitHub, Bitbucket, and you have GitLab as well. Okay, so GitHub initially it was an open source tool only. Later on, Microsoft has acquired GitHub, and right now it's a Microsoft product. Okay, and in the same way we have Bitbucket as well over here, which is an Atlassian product, and both will provide you repositories, which is nothing but storage point for storing your code, and you can store any code. You have Java code, JSP, Python, shell scripting, Terraform code, Ansible code, any code which you want, you can save over here, right? And it provides you free storage. It's very easy to create our accounts on GitHub and Bitbucket. Is as similar as to creating our Gmail accounts. You can even link your sign up to your Gmail, and we can easily have our accounts being getting created over here. Okay, simply link your accounts with Google. Okay, we will be having our Gmail IDs, right? Simply link your Bitbucket account with Google. One step process, your account will get created. Okay, so we will be creating our accounts on both GitHub and Bitbucket, and it's very easy for creating the accounts, and storage repositories are completely free for us, guys. No need to even give the credit card or debit card details over here, and we will be storing our code over here like this, right? By now we know that we are having our central repositories as GitHub and Bitbucket. So whatever code the developers are sending now, they are sending it to GitHub and Bitbucket repositories over here like this way, right? Now, and this developers machines which we are using, so as a DevOps engineers will be mostly using Linux machines. Okay, and let us assume that you have your Linux machine. Okay, so from our Linux machine we have written shell script, right? On our Linux machine we have written shell script. Now I want to save that shell script on my Bitbucket repository. Okay, or I want to move my shell scripting or whatever code you are writing, I want to move it to my Bitbucket repository over here, right? Now how to move it to Bitbucket repository or GitHub repository or any storage points? Okay, so for that, locally on this machine, locally means on Linux machine only, we have to install Git over here, guys. Git. Okay, so there is a lot of difference between Git and GitHub. Okay, people generally think that they are both the same things, but no, there is a lot of difference between Git and GitHub over here. So Git comes locally. Git will only work in your local machine. So if you have installed it on Linux machine, it would be working only on your Linux environment only. Okay, so Git will be working locally on your machine. So Git is not at your central repository. Git is at for my local machine. It would be at my local area only. Okay, and Git is developed by the same person who has developed Linux for us. It's developed by Linux Tornats only. It is the same person who has developed Linux also. So both Git and Linux are developed by the same person for us. Okay, now, so when you have installed Git on your Linux machine, on your local Linux machine, so in your Linux machine, what happens? 3 areas will get created over here, guys. Okay, and these 3 areas are very important for us. Okay, so once you have installed Git on your local machine, on our local machine, 3 areas will get created for us. And these 3 areas are very, very important for us. Okay, so these 3 areas have been distributed, okay, depending upon your code and in what stage your code is lying. Depending upon that, you will be pushing your code to the different stages. Okay, nothing but different areas. So we have a hierarchy. So we have to follow that hierarchy. We have to follow the steps. So once you are following the steps of hierarchy, hierarchy is nothing but one particular sequence we have to follow, a standard sequence. Then you can push your code from your Linux machines to your Bitbucket repositories. Okay. Why I'm telling mostly Bitbucket is because in real time Bitbucket is only used mostly, right? So the first, whenever you're writing your shell script or Ansible script or Terraform script or any other script, our code will be basically, it will be lying in working area. Okay, so no need to move your code anywhere. Once you start writing your file, once you starting writing your code, our code will be at working area over here. Okay, so this is our first stage where your code will be lying over here. That will be our working area. Okay, so when your code is in your working area, you would be having your file to be seen in red color over here. So there are some color combinations. So using these color combinations, you can easily identify that in which area your file is lying. Okay, so you can see at the working area, we will be having our file to be shown in red color, which means your file is in working area. Okay, so when you are a bit of confident that whatever code you have written, okay, whatever code you have written, if you are satisfied with that code, okay, if you are happy with that code, that whatever code you have written, then what you will do is you will move that code to the next stage, okay, to the next area, which is our staging area over here, guys. Okay, so the next area that which will be having over here is our staging area, and in staging area we'll be having our code being shown in green color over here, guys. Okay, so it will be showing you the code over here in green color. Okay, so there are color combinations, so you can easily identify that right now your code is in which area. So under staging area, where you are a bit of confident regarding your code, okay, that whatever code you have written, it's quite good. Okay, and still, if there are any more corrections or if there are more any edits in your code, you can still do that in your staging area also. Okay, suppose if you want to modify your code again, if you want to do some changes to your code again, edit your code or rewrite your code again, we can be doing it under from our staging area. Okay, now when you are 100% confident that whatever you have written, okay, is very good, and you want to show this code to your team lead or a manager, okay, when you are very much confident that whatever code you have written, okay, is the exactly giving you the same output, okay, and you are very much confident that the code will be working definitely over there, so then we will be finally, we will be moving our code from staging area to the highest point in your local Linux machine. That will be our committed area over here, guys. So committed area is the highest area, highest point in your local machine. So in our local machine, committed area will be the highest point for us, guys. Okay. So we'll be pushing our code to committed area. And when you push your code to committed area, you better not go for any color variations or color combinations over here. Understand your committed area with commit IDs. Okay, so with the help of commit IDs, we will be getting our commit areas identification. So go with your commit IDs. So these commit IDs are very, very important for us. So every commit which you do, so once you have finalized your code, okay, once you are very much sure with your code that whatever code you have written is perfectly well, okay, so then we will be committing our code, you will get one commit ID. Okay, so we will be identifying our commits with our commit IDs. So now once you are getting your commit IDs, okay, once you get your commit IDs, using these commit IDs we will be pushing our code from our Linux machine to Bitbucket. Okay, so from working area, okay, this is again very important that from working area or from staging area you cannot move your code to Bitbucket. Okay, so Bitbucket needs that commit ID. Okay, even GitHub also it needs that commit ID. So once you generate that commit ID, using that commit ID only we can push our code to our central repositories. So till you get your commit IDs, it will be treated as that your code is not ready. Okay, so once your code is ready, push it to your committed area, and on committed area we will be having our commit IDs. And once you generate your commit IDs and once we have our commit IDs, then we'll be pushing our code to Bitbucket over here. And on Bitbucket also you will find the same commit ID, because Bitbucket will identify your code from commit ID only, not from your file name or not from any logic which you have written over here. It will identify your code from commit ID only. That is the unique factor over here for us. Okay, so commit IDs will be mostly, okay, 16 digit or 24 digit long commit IDs will be there. Okay, so initial 4 or 5 commit IDs also if we take, that will work. So those commit IDs will be identified by our Bitbucket and GitHub over there. Right, so these commit IDs are very, very important for us. Okay, so this is our hierarchy. Okay, so once we have Git on our Linux machine, so these three areas will be there from where we will be moving our code in this, okay, straight sequence order. And then we'll be moving our commits from our committed area to Bitbucket, okay, in this order now. Right, now going back to our Bitbucket and GitHub pages over here, guys, now we have to first, okay, do one thing over here. We have to understand one thing over here, that initially we have to create repositories, nothing but storage points on our GitHub and Bitbucket pages over here, guys. Okay, you can call it as a repository or a repo over here. So in a short form we call it as a repo. It's nothing but our repository. Right, so now going back to our Bitbucket and GitHub pages, okay, once I continue to log in with my Google account, okay, and I will log into my Bitbucket with Google account over here. In the same one action step you can log in with your Google account from your Bitbucket. If you don't have an account, you click on sign up and you connect this with your Google account. Okay, so you will be landing upon this page, as you people will not be having any repositories on your Bitbucket page. So go for a create option over here and then select a repository. So firstly I want to create a repository. Okay, so I'll be clicking on create a repository, or if you are creating a project also it will be coming to your same page. Okay, so I will be selecting my project over here. Let me click on create. Okay, and I will give my project name as, okay, as banking project. Okay, and under banking project, okay, I will be creating a repository with the name, okay, ICICI. Okay, so we should be creating our repositories first on our Bitbucket and GitHub pages, guys. And don't go for private repositories, because if you select private repository, that would be a paid repository for us. So go for free repository. Okay, nothing but free tier repositories. So don't select a private repository option over here. Right? So we'll not be selecting any private repository. It becomes a public repository. Let it be a public repository, no problem for us. Okay, so public repositories are free repository for us, guys. We no need to pay anything for our public repositories. Public repositories are completely free for us to use. Okay, so I will not include any readme file over here. Okay, so readme file will give you the details about your Bitbucket page only. So I'll not include any readme file. And anyhow, we will go to branching. So if you don't select any branch name over here, by default it will give you main branch only. Okay, right. So now let me click on create over here. So once I click on create, you will see that repository will get created over here. Nothing but a storage point only, guys. Nothing but a storage point. So under this storage point, banking is my repository name. Okay, banking is my project name, sorry, and ICICI is my repository name. Okay, so if you want to find your repository address, okay, if you want to find our repository address, you will click on clone over here and you will see that this is my repository address over here. This website link which you are seeing over here, this is our repository address, which is nothing but our unique address. This is our storage point. So this is where we will be pushing our code, and this is where we will be saving our code as well. So you will be giving this link to your team lead and manager. We will be giving our website link. We will be giving this link to our team lead and manager so that they can come and verify your code at this link over here. So this will become our unique repository link, right? So in the same way, we will be going for our GitHub account. Okay, so I've already signed in with my account page. So let me sign in with my account. Okay, sign up is again very easy, guys. You have to just go for create account and give your Gmail IDs and login, and go for free repositories only. Okay, free repositories only. Don't select any private repositories, that will be paid anyhow. Okay, so I will be logging to my GitHub account. Okay, so on GitHub account also we could be creating our repositories, nothing but storage point. Okay, and for creating that, you have, see left side, you have a new option over here, new. From over here you will be creating our repositories on GitHub as well. Okay, so I'll be clicking on new over here. So it will ask me that what should be the name of my repository. I'll call the name over here as HDFC. Okay, description is optional, but you can say that it is for banking. Okay, or it is for e-commerce purpose, or this is for a marketing website purpose. Okay, or this is for your entertainment website purpose. So whatever purpose and description you have, you can add the description over here. Okay, and you could be doing that. Anyhow, it is optional. Now as I told you that you will be having two ways. One is public repository, which is completely free, but the issue with public repository is it will be open to all. Okay, it will be open to all, so anyone can be seeing our code. So when can they see your code? When you give your repository link, when you give your website link, so then anyone can see your code from that website link. Okay, so but private repositories are more secured repositories. So if you give your website link also, it will still ask the password which you will set on that repository. Suppose you have a storage, and on that storage you have one password. So if you give that storage address, if you give that repository address also, before showing you the code, it will ask you to enter the password over here. So that not Gmail password, you can set any password. Okay, we can set our own password on this. Okay, Gmail password is for GitHub login only. If you are logging to GitHub and Bitbucket, if you have logged into Gmail, it will directly allow you to log into GitHub and Bitbucket because you are the owner, right? But if any other person, okay, any other person, suppose you have given the link to your friend, and that is a private repository, he cannot see the code. Still, he has the password for that particular repository. He cannot view the code over. Okay, So that is the advantage for private repositories, but private repositories are paid repositories. So no need to go for our paid repositories over here as of now. In real time, you will be going for private repositories only because they want that code to be stored and secured with. They don't want the code to be viewed by anybody, right? So there we'll be going for our private repositories, right? So public repository, private repository, only difference is you see there is a lock symbol, okay, which means you have to go for applications, right? So I'll be going for a public repository. The same git ignore file it is adding. I'll not create any readme file, okay? So if you click on create a repository, the same kind of a repository which we have created on Bitbucket will get created on your GitHub as well over here. And this link which you see over here at the center of our page, okay, this is the unique address of my repository. This is the unique address of our repository. So this link, so this address and this unique link will be providing to our team lead and manager, okay? So either it's a GitHub repository or it's a, okay, Bitbucket repository or it's a GitHub repository. Working mechanism is same, guys. Working mechanism is same, either you are using Bitbucket or GitHub. That is why understanding this architecture is very important. Okay, it's just that they are from a different products over here. This is from Microsoft, this is from Atlassian, so they are just from a different company's products, okay? But working mechanism for GitHub and Bitbucket is same. You have same repository kind of an address over here. They are working as the same way as your central repositories, and both the websites we have created our own repositories. Okay, on both the pages we have created our own repositories over here. Okay, so understanding this architecture is very important over here, guys, and the same architecture which will be applying onto a real-time projects also. So whenever they are using GitHub, Bitbucket or Git, it will be followed with the same architecture over here. Okay, anyhow, practically we will be moving our code from our Linux machine to Bitbucket in the same hierarchy which I have shown over here. Using the same hierarchy, you will be working in your real-time project. The same way you will be moving your code. Either it's a Terraform code or Ansible code, okay, or a Chef code also will be moving in the same way over here. Okay, so then when we going forward, when we go for some, okay, other topics, whenever we have Git, you will be understanding this architecture. Okay, anyhow, practically at locally also we will be creating our Git. Locally also we'll be having 3 different areas, and locally I'll be moving the code from one area to another area, then I will be moving it to your central repository. Okay, but what you people will be having to do over here is create your accounts on GitHub and Bitbucket pages. Okay, these are free accounts, simply link to Google over here. Okay, because from over here onwards we need repositories. Okay, we need storage points so that we can store our code, because whatever code you people are writing, we are not storing that code, right? So shell scripting code which we have read, we did not store it. So locally never store your code onto your Linux machines or something. This is our more secure storages. Okay, so we have to always try to push your code to your central repository. Okay, from over there anybody can be getting the code, whatever code you are writing, they could be getting that code from over here, right? So create your Bitbucket and GitHub accounts and then create your repositories the way which I have created over here, because if you want to push your code from your local machine to Bitbucket, we need this repository address. So this is very important for us. Okay, so this repository address is very important for us. Okay, so taking this repository address, we will be pushing our code. Okay, so create your accounts, guys, and then create your repositories. Let it be public repositories only. No problem at all for us. No problem at all for us. Okay, then I'll be showing you guys, okay, how to move my code from my local Linux machine to the central repositories. Anyhow, we'll be moving it to from 3 different areas. Okay, and in the same way, how the things are going on real time, in the same way, we'll be moving our code. Okay, so I will be writing a sample code again, because we have, okay, some shell scripts which we have to write. So I'll be writing, okay, my shell script again tomorrow. and I'll be moving my shell script to central repository in this hierarchy. So this is the best used method. In this hierarchy I'll be moving the code. Okay, so have this architecture in mind, not only for today, not only for tomorrow, till the next 15 years you'll be using the same hierarchy. Till the time you are a DevOps engineer, you'll be using the same hierarchy. Okay, fine guys. Okay, so then create your repositories. Okay, so once you people have successfully created your repositories, we'll be moving our code from our Linux to Git, and from over here onwards we'll be seeing Git commands. Okay, so we'll be having a lot of Git commands. Using Git commands, we'll be pushing it from one area to another area. Using Git commands, we'll be modifying our code. Using Git commands, we'll be pushing it to central repositories. So we'll have to see a lot of Git commands over here. So from over here, we'll be seeing a lot of Git commands. Right? Okay, fine then. So let me just share for